All right, so section 4 covers algebraic proofs. These are properties that justify the normal algebra that we do. And so this is going to be pretty self-explanatory. I will tell you when it gets hard. So basically, if you have any equation, you can add the same number to both sides, and the equation will remain the same, like obviously. So if you have 5x minus 9 equals 12, you would add 9 to both sides, and it'll still be equal. You don't even need to simplify. You can just add 9 to both sides. For the subtraction property, you can, surprise, subtract the same thing from both sides, and the equation remains the same. So I can, for example, subtract off 7x here from both sides, and that resulting equation will be the same as well. Surprise, you can multiply the same number on both sides, and the equation remains unchanged. So I can times this by 9, I can times that one by 9. Division property, you can divide both sides by the same number, so in this case -3, and it will be the same. The reflexive property. So the reflexive property, I think of a reflection like a mirror. If you look in the mirror, you see yourself. So any number, any variable, any expression equals itself, obviously. So 9 equals 9. This is so mind-blowing, I know. The symmetric property means that there is a symmetry to the equation. If x equals -0.2, then -0.2 equals x. Now, I will say that these two tend to confuse students because they are kind of the same thing. The only difference is that a reflection is you and yourself, and so it is the same thing on both sides of the equation. While for the symmetric property, they have to be different things on both sides of the equation. To substitute, this is called the substitution property. So 2x squared minus 8 is that expression, and x equals -9. Then the expression equals 2 times -9 squared minus 8 times -9. The distributive property, multiply this through, then AB plus AC is the result. So this is -12x squared. This here is positive 20x. And then sometimes we just need to simplify things between, so I call that simplification. It's just combining like terms. So here, please look for what's different. So what I see here is that this 2x has become a normal x. That 2 that was multiplying is now gone, so that required the division property for that to work. What I see here is that the multiplication is, the parentheses is gone. So this here is the distributive property. Just look for what's different, what's gone. So what I see here is that there's a 5x and there's a... I don't think I meant to put a negative. So ignore the negative. There's a 5x there. But what really changed here was that this -1 has just disappeared. To get rid of a -1, we add. So that's the addition property. And you can also verify too, -11 plus 1 is -10, so that checks out. Now, what changed? The order. And if the order has changed, that is called your symmetric property. Okay, interesting. If 2x equals y and y equals 8z plus 4, so what I see here is that there's not only an and word in there, so that is usually a substitution property, but also that this y, can we stop? Sorry about that. And then this y right here has been replaced with 8z plus 4. That is a substitution property. What I see now is that there is a 3x squared plus 1 that then becomes 3 parentheses 5 squared plus 1. That's because x equals 5, and so this is another way of substituting. Okay. I see here we have 10x plus w equals 41. Now that becomes a -4 because w equals -4. And so this becomes a substitution property. Last but not least, I see an m and a negative 2. That becomes an 8m and a negative 16. Now we've gained an 8 here, and an 8 is before the variable, so this is a multiplication property. So what happens now is that we are going to use these properties here to justify steps in solving equations. So these are used to justify. And the template looks like this. It's given statement. There's prove statement. Now the prove is the result. Now prove, we never, ever why am I doing a W? Is a reason. I will bite your head off. Bite your fingers off. I will throw a stapler and an expo and all the things at you. I'll put you on a list to sanction you. If you ever put prove as a reason, it is never a reason. It is the conclusion. It is the last thing that we should have, but it is never, ever, I swear to God, a reason that you put down. I would rather fail you for this class and have you put prove as a reason ever. I will put this on quizzes. I will put them on tests. I will do very bad things to you if you ever dare to put prove down, because I've told you this now. It is that important. Don't do it. So, having said that, you can, and this is why I stress it so much, put given as a reason. How do we know that 4x minus 1 equals 27? It was told to us. That's it. They didn't tell us that the answer is x equals 7. They're telling us to justify that it is x equals 7. So the rest of these better be daggone properties, and prove is not a daggone property. Anyway, let's look at what's changed. This minus 1 here has disappeared. So this is the addition property. The last step, I swear to all that is evil, is never prove. Look for any property, absolutely anything that is not prove. So, what changed? This 4x just gone. That is the division property. See, it's not prove. Done. Down here. Oh dear God, why is this true? This is given. Okay. What changed from this step to this step? Well, the plus 2 is gone. So to get rid of a plus 2, we subtract it out. And then here, this minus 6 on the bottom is gone. And so that's a multiplication. Ta-da! Why is this one true? It's given. What disappeared? The parentheses right here, so that's a distributive property. What disappeared here? The plus 27, so that's a subtraction. And then what disappeared for this last step here? The negative 18 now has disappeared as a coefficient, so that's our division property and not prove. Yay. Okay, that's really simple. Insofar as you never put prove as your answer. Thank you.